Hello, I'm Kevin, and this is a tutorial on how to get started on coding in Java with no experience. No experience here pretty much means I'm going to assume you've never written a line of code, whether that's true or not. I'm trying to do a deep dive of the Java programming language and to help get people started who've never coded before, but also go beyond the fundamentals, which are usually just taught in tutorial series on Java coding. So we'll start with very much the real basics, like how do you get set up? How do you get your first Java program actually running? How do you get your coding environment up and running? But eventually we'll go through the fundamentals, and at the end you should be building full-scale web apps and doing cool stuff like connecting to databases, REST APIs, and server-side rendering, and all kinds of cool stuff like that. I should mention that all of the stuff that we'll be using here is available online and is available for free. So nothing in this tutorial will require you to buy any stuff. I'm trying to keep this as accessible as possible. In order to get started, you'll notice that I have a virtual machine running here with a blank Windows on there. I'm not going to do all of my work on here, but in this very first episode of the tutorial series, I'd like to just go through the setup requirements, make sure that everyone's on the same page, make sure that we're running the same Java version, that we're running cool things like Maven and IntelliJ and stuff like that. So if you've already got a working environment, feel free to skip to the next episode. This one's purely going to be focused on how to set up the environment itself. And before we start, maybe it's a good thing to kind of look into why Java might be a good programming language or not. So Java is a general purpose language, which means it's general purpose, right? So it's not used for one very specific thing. For instance, just making websites or just writing desktop apps or something like that. Java can be used for pretty much any kind of scenario that you have in mind. And it is, if you look at the Stack Overflow survey, Stack Overflow is basically a website that provides question and answers for technology problems. So if you run into a bug or something like that, you could ask it here and people can respond to it and vote on which the best responses are and stuff like that. And so every year they also do a programming survey. And this is the results from the year 2020. It's kind of interesting because most programmers kind of use this website just to talk to each other about, problems with frameworks and technology decisions that they need to make. And so that means that this website gives a pretty good overview of like what people are using, what are the most popular technologies, what are technologies that people like and don't like. Stuff like that. And so this is the section on most popular technologies, which I guess you can read as this is something that most people use. So it's set up between all respondents and professional developers. But the ranking up to Java is at least pretty much the same. You'll see that it's easily in the top 10 of most used languages. It's a pretty significant chunk. And if you look at the languages that are used more, essentially, if you look at HTML and CSS and SQL, these are actually languages that we'll also be seeing as part of our Java course here. So Java is a general purpose language. HTML and CSS is basically what browsers use to render web pages. So HTML is the structure, CSS is the styling, the colors, the fonts, that kind of stuff. And SQL or SQL is basically a language that you use to interact with databases and stuff like that. So we'll be using both for sure. We'll actually be seeing a little bit of JavaScript too, though JavaScript and TypeScript are kind of becoming more popular as languages in their own right. There's things like Node.js and stuff like that, which you can build entire servers out of JavaScript now, which is very different from how it used to be. So it's a popular language that's becoming more popular, but Java's definitely still in there. We'll touch on these further down the series as well. Should be said, JavaScript, very different from actual Java. They're just completely different languages. The names kind of sound similar, but they do different things. They are completely different languages, so don't get those confused. We're talking about Java here, and we'll get to these later on. But also, outside of just what developers find most popular, I think the language Java is an excellent language to give you a basis of understanding for understanding, any coding language pretty much. It's an older language that's still very relevant today. So it's been through its iterations. It is very explicit in what it wants and very wordy in what it wants, which not every developer likes after, they've been working with it for a while. But the wordiness is, I think, very good as a teaching tool, because you have to understand what you're doing at every step, and you have to explicitly type it out, what you're doing, which will be good for us here. It forces you to learn how things work. And on a practical level, there's just a lot of software engineering jobs that use Java. So regardless of whether you'll love the language or not, it's a very useful skill to have. So yeah, let's go through it here with the basic setup. So I've got my basic Windows virtual machine here. I'm using a virtual machine during this first episode to make sure that I don't have anything pre-installed. I don't make any mistakes that people might not have right away, because obviously my normal environment is already set up. So we'll start from scratch, basically. And the first thing I would want you to do is to go to the command line. So if we go to the start menu, we can type command prompt. And you'll see that there's this app here. Just open that up. This is basically the back end of Windows, pretty much. And we can do all sorts of stuff, like we can see what kind of files that we have and all that. But we'll be using this as a way to verify which things are already installed and which things are not installed. So the first thing we want to check is if Java is basically installed or not. So what we'll do is we'll do Java -- version. And this should fail, right? And that's kind of what we're seeing here. It's saying Java is not a recognized or internal or external command, which basically means I have no idea what you just said. Because it says that, we know that there's no Java installed on our machine. So that's cool. That's excellent, because then I can show you how to actually install it. So to do that, you need to install a JDK. So a JDK is short for Java Development Environment. So there's GRE, which is a Java runtime environment, and GDK, a development environment. Since we'll be developing, we'll need a JDK. JDK contains a JRE in case you want to run stuff. But generally speaking, I don't think it's that common anymore that people have JREs on their actual systems to run Java directly. It used to be a lot more prevalent. And what's interesting is that this JDK there's not just one version available. So that might be a little confusing for people who start off for the first time coding. You can get a JDK from Oracle, from Microsoft, from Amazon. There's all sorts of different versions out there. Are they really different? They kind of come down to the same thing. There's different distributions, basically, right? The difference within them is kind of neglectable if you're not super interested in what's happening. Your JDK can provide you different virtual machines that your code runs on, which basically just means like all your code does not get run directly on the machine itself, the computer itself. All your code gets run into a virtual machine. So all your code gets run into a protective layer that doesn't necessarily have access to everything. And that protective layer, the JVM, the Java Virtual Machine, gives some benefits, right? Because we can control that. We can control how big that is. We can control how small it is. If you're running multiple instances of your software on the same physical machine, it might be interesting to keep your small app, or the app that you intend to be small, to actually only give it a limited amount of resources. Right? If it runs directly on the machine itself, it might ask for more and more resources, which might become a problem sometimes. So there's like variance in how that virtual machine is built up on, but generally speaking, what you're interested in is the OpenJDK version. That's the one that's open source and maintained by everyone. That's the one that's basically leading the charge on which features get added to the Java programming language. Now, the OpenJDK has different ways of installing it, and my favorite way to install it is actually through going with the Amazon version. Amazon maintains their own version of the JDK, and they just happen to have a very easy to install process to install the whole JDK setup. So that's basically what I suggest to use. You can do whatever JDK you want. You can actually look up the OpenJDK and install that one yourself. But if you want to keep it simple, like I want, you can just go to the URL provided here, and it will download the JDK installer for you. So let's just do that. There's different Java versions too. So what you'll find is there's versions ranging from Java 6 is like the earliest you'll probably see in the wild, but nobody really works on Java 6 anymore. And a lot of companies are still kind of on Java version 8. And then in lesser extent, you'll see 11 and 16. And I believe in September, JDK 17 will come out. That sounds like there's a whole lot of version changes in between there. And what does that actually mean? There are different features that get added to Java over time. And that's basically what the versions are. There's LTS versions, which are long-term release versions, which are supported for a long time, about 3 years. And those are basically the ones that companies, enterprises tend to get stuck on, at least for those 3 years. There's, in the meantime, new versions that come out, which are not long-term support releases, which provide new features already. And basically the more leaner, the quicker companies or just individual developers can jump onto those new ones. But the long-term support ones are basically the ones that you'll see most companies using. And so that will update every 3 years, and then there will be like a whole bunch of changes. Is that a huge problem? For our course, we're going to assume that we're at least at JDK 11. And at the time of making this video, JDK 16 is the most recent one, but JDK 11 is basically the most recent support one, long-term support one that's out. So we'll go with that one for now. All these versions are backwards compatible though, so there should be no real issue if you have to jump. Let's say you start working at a company and you have to work with a completely different version. All you'll see is that certain features will be available or not available. It shouldn't be that big of a problem, honestly. So let's have a look here. We're installing our Amazon Corretto, which is the name of the distribution that Amazon has for their OpenJDK. And we can choose where to install that. And that's basically, I'm fine with all of these normal settings. I'll just install this. And this is kind of what I like. They have a nice Windows installer, which does pretty much all of the work behind the scenes. There's not that much work if you do the OpenJDK version. So basically what that does is it allows for a download that you have to extract somewhere, and then you have to set some environment variables. It's easy enough. But okay, we just finished it, and now we should have a JDK installed. If we double check here and we ask for the Java version, it'll still not know what we just asked, because for some weird reason in Windows, the command prompt doesn't really understand new commands that get added while the command prompt is open. So we'll just close this, start it up again, command prompt, and ask for the same thing, Java -- version. There we go. Now we see that we actually have the OpenJDK version. It's supported by the distribution from Amazon Corretto. But what's actually running behind the scenes is an OpenJDK, which is kind of the standard that we want. And it's version 11. The minor and patch version don't really matter that much. But you see that it's a long-term support, LTS, and the date of when it was last updated, basically. So that's great. Now we've got Java running. That's our first step completed. Now for our second step, we'll want to verify if we have Maven installed. Maven is a build tool. We'll get to that later, what that actually means. So when we'll be writing code, it will be a high-level abstraction, essentially, of what the computer has to do. And we'll write that out in our code. That's why we call it code. It's the abstraction. And then once we're done with it, we'll essentially compile it into something that gets that is runnable for a machine, or in this case for our virtual machine. And compiling is basically just like translating to machine code, basically. We're not going to write in a way that is directly hitting the virtual machine. We're kind of going to work on a more abstract level. So we can work on a layer that is easier for us to read, is easier for us to develop with. And then once it's compiled, it's easier for the machine to actually run it. We don't need Maven for that particularly, but Maven can help us doing some pretty cool stuff. So it can help us make that build, and it will also be able to help pull in different code from other people to combine it and make that into a runnable thing. But we need to download it first just to get our development environment up and running, and we'll get deeper into what Maven is. So just to verify if we have Maven installed or not, I'm just going to type mvn-v. So when I do that, it's going to give me the same thing, Maven. I have no idea what you're talking about. What is Maven? So for the next step, I'm going to download Maven here, the latest version. I'm going to download the zip version because I don't actually have any fancy compression tools installed on my system right now. You can use whatever you want. So you can choose the tar.gz or the zip here. I'm downloading the zip right now. The other ones here are not really relevant to what you're doing. These are like the checksums and stuff like that, to make sure that you're not downloading something that's unexpected. So we're just going to open that up, and we'll see that there's a folder in there. And I'm actually going to extract this folder and move it to a location that makes sense. So in my case, that's going to be C users, my name, and then I'll make a map. I'll make a folder called Maven. There we go. So I've extracted it here. And then we get to do some fun stuff. We'll need to make sure that we know what the bin folder is. So you see that if you've installed it somewhere and you've extracted it, you'll see that there's a folder in here called bin. Just click on that and make sure that you've got the path correctly to where that is, because we'll need that in a second. And then we'll basically do what it says here. We're going to view advanced settings, view advanced system settings. And we're going to make some environment variables. and one of our environment variables is our path. So what we're going to do is we're going to edit our path, and we're going to add a new one here, and that's going to be our bin folder. Press OK, press OK, OK. Make sure you've got your command prompt turned off, and then turn it back on again. And we'll type maven-v again. And you'll see that we now have Maven installed. So just a quick background on what we did here. Path is basically what the command prompt uses to search through when you type in something that it doesn't natively know, right? So if I type in Kevin here, it has no idea what I'm talking about, but it will look in the folders in the path if there's anything called Kevin in there. There isn't, so it doesn't work. But if we look at the bin folder here for Maven, there is an MVN file in there. Specifically this one, actually, the Windows command one. So as soon as we type MVN -v, it knows to send -v to essentially this file. That's basically just what's happening behind the scene. And we can see, hey, we have Maven running. It can find our Java version, which is the Amazon variant. So that's great. That's all working nicely. And we can just confirm that our path is set here. For the next step, we'll need to install Git. Git, we'll do a double check here too. Git --a version, but we won't have that installed yet either. So Git is basically a source control system. That sounds difficult too, maybe. What that does is basically when you're writing code and you're confident that something works, you want to save that code somewhere. You want to make sure that there's a backup. And as you're experimenting with new features, as you're writing code and stuff like that, sometimes you'll do something wrong and you want to go back in the history of what you've done. You want to go back in a backup, basically. But you don't always want to keep actual backups. You don't want to have your entire project turned back. Sometimes you want like just a file here or just a file there. And sometimes you want to do multiple experiments at once and you want to switch between them. That's basically what Git allows you to do. It's not really a backup system. It's called a source control system. So it saves your code in a remote place and it can kind of abstract around it so that you can switch between versions, switch between branches essentially of your code, different versions of what you've written, and it can merge those together. You can look through the history. This is especially useful if you're working with multiple people too, so you can see who changed what. You can both work on your own versions of code and then merge it together very nicely. That kind of stuff is what Git takes care of. So we're just going to select the download for that here and install this too. Should be pretty straightforward. This doesn't super matter. I think the defaults are fine for this. I'm fine with this too. This is basically the initial branch that it will make. So you're always working in branches. I think we'll want to change it to main just because our source control system will be using GitHub. They try to use main now. I'm totally fine with it if you also use master. It's kind of a convention just to kind of use something like master, main, trunk, or development. Master used to be the one that everyone was using, but because it kind of has a weird connotation with it concerning like master and slave, those kinds of connotations, which are, you know, meant as computer terms, but can be interpreted kind of weirdly, I guess. Just to get away from that, the new choice, new default choice tends to be main or trunk, actually. Development is usually a branch that's available as well, but I'd like to make a distinction between what's main and what's development. To me, main is like your finished code, right? It's either your finished code or the only branch that you're working on. If you're not interested in using branches, to me, you just call it main. If you're interested in using branches, you have a main branch which reflects what's currently like your best version, and then any ongoing work, experimentation starts from a development branch. That's kind of how I see it, but it's not super important. For all the rest of this, I'm just going to go through all the default options. It's not really that important for us. I'm not going to go into all of these because we're just going to use this in a very limited fashion. We're basically going to focus on checking out mostly, which allows us to download code or examples of code. And we're going to focus on committing and pushing, which is literally saving our code onto a remote system. Again, this will be, we'll further explain this in a future episode. It's not super important right now. Just going through the install process of making sure all of our files are there. We don't need to see the release notes. The only thing I'm interested in, I'm just going to close this again, make sure that it knows what I'm talking about. Git -v. Yeah, okay, sorry. It's git -- version. That's the version check. I was a little confused there. Although this already shows as well that it knows what Git is, and then it gives me a few helpers here. And it actually suggests minus version right here too. So, okay, we've got Git installed. Now we have to do our very last step, and that is, where are we going to be writing code? That kind of tool where we'll be writing code is called a IDE. There's different preferences that people can have, but for the tutorial series that we'll be doing here, IntelliJ is the one that I suggest you to go with, just because it's very high quality, it's free to use, and it's kind of fun to use too. It takes a bit of the overhead away from you from working with code. It kind of integrates things nicely. We're just downloading it now, and that should be our last step. Okay, it finished the download. I'm going to run this executable. I'm fine with where it's saving things. It's probably good to create the associations with the files. We'll actually only be using the first one. You can add the other ones too in case you want to. It's not really that important. I'm on a 64-bit launcher right now. And why not add it to the path? Sure. Again, the details of those options are kind of less important there. IntelliJ has a paid version as well, which adds a couple of convenience features. I think if you're just starting out programming, it's not worth it at all. Once you're established, your company might get it for you. If your company doesn't get it for you, it might become interesting depending on the kind of code you do and depending on how much time you spend in, your IDE. But the community edition is very much good quality too. All right, great. Just to finish up here, it wants to reboot our system, so we'll just do that right now. This will reboot my virtual machine. But that should be the last step to start writing code, basically. So I'll just double check that everything starts up properly. And if it does, I'm going to switch to my main computer, not the virtual machine, and actually run most of my code there. So you don't have to see this tiny screen, but you can actually see the full screen as intended. But that should be it for our setup. And the next episode will basically jump into our IntelliJ for the very first time and start writing some code. And I'll start explaining how you can do some very simple things at first and give you a little overview of how the IDE actually works. Okay, so we're starting our IntelliJ for the first time. It's just going to ask for the community terms and basically asking you to agree with the user agreement. It's a community edition, so IntelliJ is not necessarily responsible for if there's stuff going wrong that much. I prefer not to do data sharing, and we're going to see that it starts up with our little splash screen here, and then it will jump into a bigger code view. And just double check here if there's anything we need to do at the very beginning. Usually these setups you do like once in like 5 years or something like that. So it doesn't really happen that much that you start from scratch like I'm doing right now. So I'm kind of curious how quick you can get up and running. All right, for our very first screen, we will get a Welcome to IntelliJ screen. We can choose a couple of things here. We'll be interested in customizing this further later, but for our very first tryout, we'll just select create a new project here. And we'll select that we want it to be a Java project. It has our SDK already, and we don't have to specify a library. We'll select next. We don't need to build it from a template here, and we'll give it a project name like initial underscore test or something like that. And that should be all. All right, when you first start, it will try to bombard you with a couple of things here. Tip of the day, I don't think that's very interesting. I'm just going to say, don't show any tips anymore, and I'm going to close it. So it's not going to bother me with that anymore. Code with me is an interesting new feature, but we're still learning how to code, so we're not actually interested in doing this with a team right now. What's new in IntelliJ IDE, not really interested in that right now. And this is kind of the screen that I'm hoping for. This is my project here. We'll have our SRC folder, our source folder, which we'll be writing our code in. And in the background, we can see that it's starting to download a bunch of indexes, which will make our lives much easier. This takes a while. Give it a while for it to complete. And once it's completed, we can get started with the next episode and actually start writing some code.